Greetings, precious. Good morning and good evening, wherever you are. I am extending the warm greetings to all and welcome you all for this video lecture series on Explainable AI. In this topic today, we are going to discuss about another concept called SENN. What is meant by SENN means that is nothing but self-explainable neural network. That is what our topic of interest today. In the previous lecture, we have demonstrated about concept whitening. So what is meant by concept whitening? Everything we have discussed in detail, but apart from that, today also I am going to take a walkthrough on concept whitening, how the concept whitening are happening and what is the difference between concept whitening and SENN. That all are we are going to see today. Meanwhile, before starting to this, we are dealing with concept-based explainability. Previously, we deal about some sample-based. Now we are going to create concepts based on the scenario, how many concepts we are creating, and based on that, how that logic can be converted into explainable terms. That are all we are looking into. So now coming to the self-explainable neural network. This is also a interpretable model. Okay, so this is also a intrinsic process only. But what is the difference we will see now? So where predictions are explicitly computed as weighted sums of interpretable concepts. So here we are going to add weights. Previously we add axes. Now we are going to add weights. So what previously we did means we we take some concepts and we are associating that with some axis values. So for example, C1 corresponds to this axis and C2 corresponds to this axis. Based on that, when we add new axis, in which direction it is coming, that concepts we are associating that with that concept. That is called as concept whitening. Now we are going to do in terms of weights. We are going to add the weights also. So weight themselves learned functions of the input. So based on the input, the weights themselves are learned. That is called as self-explaining. We are assigning the weights that itself self-learn about the functions of the input. This is what we are going to see today. So the SENN prediction is based on alpha. You can see here CI of X. This only we see in concept whitening. And here we are going to add some alpha I of X. Alpha I of X means relevance scores. Based on the relevance scores also, we are going to do the prediction. So that these weights and these concepts, how they are going to relate with each other, that we are going to see in SENN. Before that, concept whitening is nothing but changing the dimensions of neurons, changing the dimensions of neurons according to the concept. According to the concept, the dimensions of neurons are changed. And based on that, we are explaining. Now we are going to change the architecture frame of the output layer. Architecture framework of the output layer, that is called as SENN. We are not going to touch the neurons, but neurons are telling some concepts. Based on that concept, we are going to change the architecture of the output layer. So how the output layer we are going to change according to the received scores. That is called as self-explainable. According to the scores, this framework will rechange itself for suitable prediction. That is, it is self-explaining itself based on the scores received from the neurons. This is called as, that is why the name self-explaining. So based on the scores, it will redefine itself. How we are not going to do anything manually or no human interruption is required. According to the score, the output layer is reframed themselves, and like this scores, according to the scores, this alpha I will redefine itself in order to do some prediction. That is called as self-explainable neural networks. Okay, so here we are having two things. One is called as concept encoder and another one is called as parameterizer. So if this is just for example I am giving, this two give means we are going to split this into, first we are going to disentanglement. That means those who are associated, this is the mixture of several pixels. First we need to decorrelate all the pixels. We need to decorrelate. That is, relationship will should be broken. So each and every pixel will be associated in the individual format. And after that, we have to decode the concept. And then after decoding, we have to give the relevant score. On adding this decoding concept, that is alpha I along with the wi, we will get the prediction. On summing all these things, plus alpha 2 into w2 plus alpha 3 into w3, based on the sum, based on this sum score, I am going to do the prediction. That is called as this alpha I 1 2 3 will be parameterized. This is auto. We are not doing any. This is only the algorithm is doing. These are relevant scores based on the concept. Okay, these are the relevant scores generated based on the concept. That's why this is called as, according to the concept, this scores will be generated automatically. That is why this is called as self-explainable. It itself defines its score automatically. That is why this is the concept of the thing. So first we will see in a layman method. After that, I will take you into concept whitening. Along with that, SENN I will discuss. So here a patient arrive at the emergency department with the following symptoms, that is fever, cough, and chest pain. So the AI must predict the medical risk and explain its decision clearly to the doctors. This is the scenario what we are looking for. A patient is coming to the emergency department with fever, cough, and chest pain. So AI model, it is supposed to be the what we call patient data are supposed to be submitted to the AI model. So what AI model should be done before diagnosis? It should predict whether the patient has any medical risks or not. So, and it should explain its decision clearly to the doctors. So the doctors will compare their decision and AI model decision, whether they're for cross verification. Okay. But finally, doctors decision is the final, but it is for just for cross checking. For example, we are deriving one problem and we are getting one result, and this result can be verified in some other way, another method, in order to ensure that the way, in order to ensure that what we have derived is correct or not. In the same manner, doctors are predicting that okay, this is the thing. In order to cross verify, due to the advancement of technology nowadays, doctors can clarify whether our working methodology is same or deviating, that they can able to ensure. So that doctors can trust the prediction. Critical symptoms must be highlighted and black box decisions are unsafe. Just relying a AI model is unsafe. In turn, if the AI model explain all these things, then the doctor can able to gain the trust. Okay, this is doing based on this scenario. So yeah, it will increase the trust and ethical things of the particular model. So let us, these are the concepts. What are the parameters a patient are coming, that we are calling it as concepts here. Hereafter, everything we are not telling it as samples or data, we are calling it as concepts. Fever is one concept, cough is one concept, chest pain is one concept. The symbol for fever we are denoting is a concept 1, and cough is denoted as concept 2, and chest pain we are denoting it as concept 3. So moderate fever, the value will be 0.7. Mild cough, it is very low weightage 0.2. And C3, this is severe chest pain. It gives highest weightage 0.9. These concepts are clinically meaningful. Since chest pain should be treated very severely, so it gains the weight of 0.9. Mild cough is, we can just a simple medicine can cure it, so it is 0.2. Moderate fever means some sort of medication should be done, so that light higher value we are giving, that is 0.7. So the values are normalized between 0 and 1 normally. Okay. So SENN model learns how important each concept is for prediction. Okay, this is the important stage. So alpha, based on this previous thing, is the value given by the model. So based on the model, SENN is learning what weightage we have to give. For example, it is giving alpha as 0.4, this as 0.1, and this as 0.8. So zero point 0.4 is moderate, 0.1 is very low, and 0.8 is maximum. So the weight gained by the SENN is moderately important, that is 0.4, very low importance 0.1, and chest pain 0.8. Like that, the model is trained. So now what we are going to do, we are going to multiply this zero point 0.4 with the gained value. You can see here. So SENN produce explanation based on concept into relevance. So this is the concept given by the black box model, and these are the weights gained by the SENN. So on multiplying these two, what happened? That is our main aim. So you can see here now the concept, that is 0.7 into 0.4 will give you, even though this parameter is very high and this parameter is also, so it gives 0.28, and this will be 0.02, and this will be 0.72. So based on this, what we have, we can tell that the chest pain scores the very high contribution in spite of concept as well as its weightage. So each contribution shows how much that symptom influences the decision. So how it is predicting means, irrespective of the concept, it is also gaining the weights. And based on the multiplication also, it is getting the highest weightage. On that basis, it is predicting that chest pain is the. So total model weightage you can check 0.28. Okay, here you can see 0.28. 0.02, 0.72. These three things we are going to add now. If you add means what you are getting 1.02. This is very important thing. We are adding all the three values and we are getting the value as 1.02. 1.02 is nothing but high prediction score. So that is, the risk is very high. On what basis means, after that we are calculating which is the highest contributor. 0.72. 0.72 is nothing but my chest pain. This can be look very simple when we are doing this numerical mathematics, but when we are handling more than 10,000 data sets and we are presenting one patient, and based on the scores learned, it has to gain the weights, and after that it is computing and it is telling the answers means, then the trace back facility is available. So based on the trace back, you will get the summation of different weights. For example, here only three weights are coming. Okay, so if you are getting 500 weights, so apart from all the 500 weights, it is having very highest score, and which is the most contributing factor, and that concept is associated to which thing means, which concept means, we can able to tell, okay, this is out of this all these things, it is concentrating only on a particular parameter that has most weightage, more weightage. So the model predicts the serious condition requiring for urgent attention. This is the thing what we are doing. So chest pain dominates because severe chest pain 0.9, high relevance weight critically important. Okay, clinically critical, that is 0.8. So other symptoms contribute very less. That is, cough is mild and low priority. Fever is moderate but not life threatening. So matches with real medical reasoning. This is what the model explanation, human readable format we can give. So these are all the things what we are, but that is called a self-explanation. So apart from that, I am going to give you a small takeaway. What thing we are going to do. So SENN is an intrinsically interpretable neural architecture. Okay. Human readable explanation as part of its prediction process. What I am telling is pure SENN, and it is giving a overall outline I have given. Now we are going to compare this with concept whitening. That is what I have In the initial slide itself, I tell you, I am going to take a small walkthrough through concept whitening, and then I will go to solve the SENN so that you can able to understand very easily. So concept whitening is what we are learning the concept and we concept into the decorrelated axis. That is, decorrelation means what? Initially, all the concepts are mixed together. In the last slide also I explained, a purple is there. After that, after decorrelation, it is split into two things. One is red and blue. If you mix together, it becomes purple. So after decorrelating blue and red, red is assigned to one axis and blue is assigned to another axis. This is what concept whitening is doing. First, the concepts are splitted into individual concepts. Entire scenario is splitted into individual concepts like fever, cough, and in the same manner it is splitted into individual concepts, and then we are fitting those concepts according to the axis what we are having. So SENN is designed to produce concept activation plus linear combination of weights. So pure SENN is available, which concept whitening will not be used. Just before I discussed, that is called pure SENN. It starts from scratch. It will learn from the model what are all the scores it is given, and based on the score, it will assign the weights. So if the score is above, that means it will assign very high weight. If it is below, means it will very low weight, and then it will do some multiplication, and finally it will estimate the score. And for that score, which is the most highest contribution factor, we can able to check it out. This is the thing pure SENN is doing. Now we are going to, but for better practices, we need to do concept whitening plus SENN. That is called hybrid. If you do hybrid, means more justification is possible. Let us check. I am generating a pixels. It is given to a black box, and then concept whitening is applied so that I will get scores. And after that, it is given to SENN, a head weights. That is called as weights gained by the SENN as that of, and then prediction. This will give you a better understanding. Okay, let us check. Birds classification example I am taking for realization. Now you listen carefully. This is the most important workout. Assume the chosen hidden layer has two neurons. Only two I am taking. Giving features, two neuron has features F1 and F2. There we can C1 and C2. Instead of that, here I am assuming F1 and F2. The four concept examples are, I am taking it as eagle, hen, penguin, and fish. These are the four categories I am taking. From this, I am going to classify which are all birds, which are all non-birds, like that. So first you have to learn all these things. First one is eagle. Eagle can fly better, and this belongs to a bird category. Okay. Hen. It can fly moderately. It has wings. It is also having wing, but it fly moderately. It is also a bird category. Penguin. This is also a bird category, but it does not have wing and it cannot fly. Flying is not possible and it has no wings also. A small flap is available. But next one is fish. Fish is not at all a bird. It cannot able to fly. These are all the categories. So in this, what we are doing, so I am declaring two axes. One is for bird and another one is for non-bird. This is the important thing. Two axes I am declaring. So for that, the black box model is creating some assumption, or what we call some features it is generating. Eagle it is generating 2,1. Why means 2 is positive for flying birds and moderate for seconds. That is C1 and C2 I am taking. This one is C1 and this one is C2. C1 is for C1 becomes positive, very high positive for birds, and C2 becomes very high positive for non-birds. So you can see here, for eagle, C1 is high. 2. And second feature is moderate. It is not a fish. So it is moderate, but we cannot tell it is not a fish since neuron cannot identify whether it is a eagle or a fish. But due to flying posture, it is classifying it as as it is looking into the wings, it is telling that it is 2 and it is 1 moderate value. And similarly hen, it is having less flying feature, so it is 1.5. Usually hen will be on the land, okay, land surface. Eagle will be in the flying position. So based on that I am giving moderate weight. And the second feature is not likely a fish, that is it is not a it is for non-bird category, it is a bird. So I am assuming it as a moderate value. Penguin does not have, that is, this is not a bird category, that is minus 1.5 and 0.5. Minus 1.5 means it don't have wings. Okay, and even it cannot fly also. Penguin cannot fly. That's why I am giving negative value. Those can fly, positive for flying birds. I understand the word carefully. So penguin is not a flying bird. That's why it is given minus 1.5 comma moderate value 0.5. And finally fish is not at all a bird. So 0 comma, but it is belongs to a non-bird category. That is nothing but high for fish. That is 0.3. In that manner only, let us assume that the neurons are fixed in that manner. Okay, by training, a black box model is assigning suitable weightage by means of this manner. I am not assuming, the model is assuming like this, we are telling. Okay, in the next step what I am doing, I am creating a data matrix. How we are creating data matrix? 2 1 1.51 minus 1.5 0.50 comma 3. This we are generating in as a matrix. Okay, these are generating as a matrix. This is what we are called one row per image. This is for eagle image. This is for hen image. This is for penguin image. And this is for fish image. Okay, so one row for one image. This is called as data matrix. We are forming a data matrix, that is one image per row. Okay. Next, what we are doing, we are computing the mean over 4 samples. That is centering of data. In concept whitening, initially the graph will be in this form, that is in the form of stretched manner, like this. All data will be like this, in the form of stretched, like this only. It is accumulated like this only, like this. It is in the form of stretched manner. In the last class, we have discussed. But after computing mean, what it is having means our data will got center, and around that all data will come like this. So from center you can take axis like this. So this is the importance of concept whitening. That is why we are doing all these things. So first we have to calculate the center the data. How to center the data means mu is equal to 4 samples. So 1 divided by 4 into all the data. 1 by 2 by 1, 1.5 previous slide. Okay. 2, 1, 1.51 minus 1.5.503. Here we are taking all the things. So 1 by 4 into what we are doing, we are adding all the things. So you will get 2 here. And here also you will get 5.5. If you divide it by 4 means I will get 0.5, 1.375. Okay, this is the centering of the data center. So all the data we are finding a center point according to C1 and C2. Two features we are estimating now. So for that the center point will be 0.5 and another center point will be 1.375. So then mean centered data, what we are calculating, 2 minus 0.5, 1 minus 3.75. What is this? Let us check. 2 minus 0.5 means this is the mu we have calculated. So from the first data, we are subtracting this mu. 2 minus 0.5 comma 1 minus 1.375. This value I am subtracting each and every individual values. So 2 minus 0.5, okay, minus comma 1 minus 1.375. So I am getting what? 1.5 comma minus 0.375, which is nothing but for eagle. EC means eagle center data. And similarly, I have to calculate for hen center data. That is nothing but 1.5 minus 0.5 previous slide. 1.5 minus 0.5, 1 minus 1.375, which is nothing but 1.0 minus 0.375. Similarly for penguin, this value, and similarly for fish, this value. So finally, I am computing a matrix, centered matrix, that is nothing but what? Okay. So fine. Okay. So 1.5 minus 0.375, 1 minus 0.375, minus 2, 0.875, minus 0.5, 1.625. This is called as mean centered data. And first one is data matrix. Now this is the data centered matrix. Okay, two things are possible. Now we are going to see what actually the whitening is doing. So 1 by 4 into XC transpose into XC. That means first I am calculating F1 square. That is 1.5 square, 1 square. What is this? These all these things. 1.5 square, 1 square, minus 2 square, minus 0.5 square. If I compute means I am getting the value 7.5. Second component, minus 0.375, minus 0.375, minus 0.875, 1.625, all squares. I am getting the value 3.6875. After that, cross terms. If you multiply the cross terms means you will get the actual value 0. Now you can see that how the values are coming. 7.5 cross product is, this is 1 1 1 2 2 1 2 2. 1 1 and 2 2 gets value. This is first component and second component. Cross products 1 2 and 2 1 becomes 0. Okay. So 7.50, 3.6875. Hope it is clear up to now. Now what I am doing, I am going to multiply 1 by 4 into obtained values. So I am getting 1.875, 0.921. So after that, what I am doing, whitening matrix. This is called as concept whitening. What we are doing, that is square root of 1.875. I am getting the value 1.3693. If I scale it between 0 to 0.1 means 0 to 1 means I am getting 0.730. And the second variance also I am getting this. Now I am replacing the value with whitening matrix 0.730, 1.041. Okay, this is called as concept. Now 0.730 is separate, 1.041 is separate. Two are totally divided. Okay, now what I am doing is, now I am going to explain you about the whitened features. Listen carefully. This is the ultimate important stage. So what is the whitened feature of eagle? Eagle whitened feature 1.5 dot 0.730. What is 1.5? Let us check. Okay. 1.5. Here you can see this is 1.5 into 0.730 minus 0.375 into next axis 3.6875. This is the thing what we are not 1.041. Okay, this value you can notify. Take these two values into consideration. 0.730 into C1, 1.041 into C2. So here what is C1 and C2? 1.5 is the C1 minus 0.375 is the C2. I think you remember all these things. Now you can check here. Slowly you check 1.5 into 0.730 minus 0.375 into 1.041, which is approximately equal to this value. Multiplication. 1.0, this is dot. Don't confuse. This is just a dot. Okay. This is just a dot product. This is a dot. This is also a dot. So similarly for hen also I am calculating, for penguin also I am calculating, for fish also I am calculating. So I am getting 4 different whitening values. This is called as whitening scores. Now you can check here. Axis separates eagle hen from penguin. You can see here. These two are positive in nature. But this one is negative in nature. Those who are in positive in nature are birds. Already I explained. These are positive for flying birds. If it is coming negative means it is a bird, but it cannot fly. Okay. And this is very weak. So it cannot be actually a flying bird also, since its quantum is very negligible. Second quarter I am checking 0.390. So second quarter is, it should be a fish. So negative is coming, it should not be a fish. This is also not a fish. This is also not a fish. In the second category I am checking, I am getting 1.692. That means which are having C1 greater than 0, that are called birds. Which is having C2 greater than 0, that is called fish. Which is having C1 negative. Okay, C1 negative, that means what happened? C1 negative means it, but C1 negative but strong negative. That means what happened? It is not a flying bird, but it more or less equal to a bird that cannot able to fly in between. So under the fourth axis, already I explained C2 is greater than 0. So in the second axis, its second axis also negligible, so it cannot be a fish. So like that, the concept of whitening is based on the scores, it can able to predict what it is. Okay. So the axis 1 separates eagle and hen from the, so this form one axis. This is eagle bar hen axis. And this form another axis, that is fish axis. But penguin is lying neither in this axis or in this axis, that is minus 0.1460. Positive axis it is not possible, fish axis also it is not possible, so it lies somewhere. That means it is not oriented with eagle or fish, so it is automatically what? It is a penguin. Since we are giving only 4 labels: eagle, henna, penguin, fisha. It is not a fish, it is not a eagle, it is not a hen. So automatically it is what? Penguin. That is what this concept whitening. So if due to the whitening things, this what I am doing is whitening. Whitening means what? We are separating each and every values. Eagle, hen separate, fish separate, penguin separate. By means of concept whitening, what I am doing, I am extracting a completely a feature. So cluster roughly around 0.9 and minus 0.39. Penguin around 1. This is 0.9. How it is coming means you just add and take a average. You will get 0.9. This will be 0.39. So approximately 0.9. So this is positive. Okay. And penguin, this is negative. But it first coordinate should be positive, then only it is a bird. And in the fish it is negative, so it is not a bird. So what second coordinate I am checking, this is negative, this is negative, so these two are not a fish category. This fish category is positive in nature, so we can declare that as second coordinate is positive, it is a fish. As first coordinate is strong negative, I can tell it is a bird, but it is not a flying bird. First quantity is strong positive, I can tell this hen, eagle and hen will form a bird category. This is how the concepts are explained. So if a model is giving a prediction means, based on the cluster, we have to check the scores. Either first coordinate is positive or second coordinate is positive. As per the prediction, the first coordinate have very strong positive value means the predicted concept is perfectly correct. This is what the thing we are going. Okay. Now, I think it is understandable. This course we are getting now 1.095 this course. Now I am passing this score to SEN. Instead of taking raw data, already whitening concept we processed and we can come to a conclusion also. And we are now what we have to do, output layer we are going to explain. Now already we have explained about the neuron and its dimensional changes. Now I am going to explain you about the output layer, how the output sees the neuron activation. That I am going to explain. So what I am telling, neuron internal dimension changes. This dimension changes according to that how the output layer also getting changed. And it is seeing the neuron dimensional changes perfectly or not, that is called as self-explainable. According to these changes, it has to self-change itself to predict the output according to the dimensional changes of neuron. That is called a self-explainable neural network. So these things already I have explained to you, though, so there is no need to explain. Now what I am doing is I am going to do one more thing. I think these values you already know, right? Sorry. This is the whitening matrix 0.730001.041, where the weights are coming. Let us check here. This one, right? This light. So same thing, I am that value only I am taking here. Instead of going to the past values, just multiplying the equivalent weights according to the category, just I am taking the concept whitening score. That will be more accurate. So first I am going with penguin forward pass. If I am going with penguin forward pass means what? Minus 1.5 minus zero point 0.5, zero point 0.5 minus 1.375. These things I think you know already what we are doing. Okay. So what is this minus 1.5? Check out penguin. Okay. Check out what is penguin. You can see here same calculation I am taking. Uh, okay. Minus 1.5 minus 0.5, zero point 0.5 minus 1.375. Centering of data. That I am once again recalling here. Okay. So same thing. So we are getting minus 2 minus 0.875. Same value. Now what I am doing, I am multiplying this with the whitened values. 0.730 into minus 2, 1.041 into minus 0.875. So what I am getting, minus 1.461 minus 0.911. C1 is greater than 0. C1 should be greater than 0. C2 should be very higher than 0. But these two are not satisfying. This is strong negative. This is negligible. So but the values obtained clear that it is neither eagle or hen or fish. So it is a penguin. This is what already I explained. Now, I am introducing a new concept called horse model. Now, what happened to horse? If I give horse means, then everything should be retrained. That is the question. No. What happened? We are just calculating the concept whitening scores for horse. Suppose horse, using the same concept, suppose I am getting the value as 0.511 and minus 0.599 I am taking, for example. So what concepts we are taking means, for example, it is having horse cannot able to fly. Okay, horse is not a fly. So I am assuming an suitable weightage, and second coordinate, it's getting the suitable weightage, just like that of, okay, 1 minute. Just like that of eagle and hen, it is gaining the weight. No? So eagle can fly, the second weight is moderate, but here what I am doing, horse cannot fly, so I am assuming some low values here, and then second value should be high or moderate level. It is not a fish, so it is a small but higher values. Based on that, I am doing all the concept whitening steps, and based on these things I am getting the value 0.511 minus 0.599 I am getting for C1 and C2. Okay. Suppose Horse score is nothing but A into C1 of X plus B into C2 of X plus D. D is the bias. Horse like hen, eagle or hen side. That is, it is not a fish. Okay, so it is not a fish, but the how it is assuming the weight means horse will look like this, no? Like for example, this is the horse image. Bird image also like this only. It has feathers, but you can see the similarity. This is also flat. This is also flat. So it looks only the orientation. That's why it is giving moderate weight to A factor, eagle or hen side. Horse, fish is totally different. It is like this. Fish is totally aquatic. So it is not horse dislikes since it don't have legs. Okay. So the flat body portion, it is also having head, beak, all these things. It is also having some similarity like this. So the orientation looks similar in terms of the not the image, but in terms of orientation. But if flesh image is totally oval, it should look like this. So instead of giving 0, due to the flat appearance, I am giving minus 1.0.5. It is gaining on seeing the irregularity pattern it is assuming, and the bias is 0 simply. Okay. Next, what I am doing, I am calculating the horse weightage. How to calculate the horse weightage? Let us check. So 1 into C1 of X minus 0.5 into C2 of X. What happened to eagle? 1 into 1.095 minus 0.5 into minus 0.391. This is the thing. Okay. This weights. This weights. Weight and factor weights we are having now 1.095 minus 0.390. That we are multiplying with horse value. That is the speciality of SENN. So if you give one new concept means already available concept, it will multiply. This is called as self-explaining. It will explain itself. So according to the gained value about horse, it will redefine its already available things. That is called self-explaining itself. So 1 into 1.095 minus 0.5 into these things. So I am getting 1.2905. For hen also I am getting one value. For penguin also I am getting one value. And for fish also I am getting another value. Now what I am doing, horse value 0.511 minus 0.599, I am getting 0.8105. Now this is the important step what you have to understand. Now, based on the computation of scores, I am getting the conclusion that 1.295, what happened? It is greater than 0. It is greater than 0. 0.925, it is also greater than 0. Horse is also greater than 0. Whereas penguin and fish, what happened? These are less than 0. Now you can see these two things form one axis and these three things form another axis. So if you compare this value 1.2905, this is strong positive, very greater than 0. That means first coordinate very greater than 0 means as per the rule, what is the thing? If C1 is very greater than 0, then it belongs to either hen or eagle category. Okay, as per the rule. If it is just greater than 0 means what happened? It very greater than means it belongs to eagle. Just greater than 0 means it will belongs to hen category. And then one more thing is just greater than 0. So what we are doing, this is also belongs to hen category only. So we need to compare. So one thing, it is not a eagle, but the value is slightly below than the hen. The hen category is 0.9. It is not 0.91. It is below 0.81. 0.81 means what is the thing we have to do? We have to imagine that the given image is not a eagle, not a hen, not a penguin, not a fish. So what label the input black box is given with the input? It is given with the input as horse. Then it is nothing but a horse only. Since the score indicates the score itself, we are mapping. So eagle score is 1.205. It is not a eagle. Hen score is 0.9255. It is not a hen. In bad category, it is not at all a bird, first of all. Next 0.8105 it is coming. So 0.8105 means it is other than fish, other than penguin. It is nothing but a new creature. Whatever the label you are giving, that is correct. This is what the self-explainable learning neural network is telling. So you don't know the label. If you supply the label means it will tell yes, it is the horse. Okay. So this is exactly a SNN head built on concept whitening feature. Concept whitening supplies the concept. SENN gives a linear self-explaining decision rule. If that score is in this range, it is a eagle, it is a hen, it is a penguin, it is a fish, otherwise it is a horse. Like that, it will declare. It is self-explain itself and it will make the prediction. This is called as according to the concept whitening scores, the architecture will reframe itself all its weights. What are the computing weight already? Everything will be remodified and the new score will be fit where it come. It will be in between or whatever may be, it will come. So this is how the self-explainable neural network gives you much prediction. Just like simplification using GradCam or Lime or Sharp for post hoc analysis, you can go with this self-explainable neural network ability so that you can able to uh, predict the things in the on pass itself. Forward pass itself, you can able to see all the things. That is the prediction is correct or not what itself. So you are in this method while hybriding both concept whitening as well as SENN, you can see which neurons are associated, what are all the axes, correlating axes, and that values you are giving to SENN. Based on that, SENN is gaining head weights and all the previous factors what it is calculated already everything is redefined, and according to the new value it is re-estimated, and we are checking that whether the obtained value new value is matching with the prediction result or not. This is the concept of self-explainable neural network. Hope you understand this walkthrough in a better manner. But once again, I am telling all this mathematics for all are for our understanding only. But when you compute self-explainable neural network in they don't think this only it is doing. It is just for our understanding. It is handling with million and million of neurons. You cannot even compute all this mathematics. If you compute the mathematics means it will take more than 1 year to solve all the things what individual neurons are doing. Such a complicated process. For that only we are using Python tools and other things to handle it in a thing. Once we have to understand how the neurons are activated, what is the internal process actually happening. For that purpose only we are taking a small tiny toy model having only two features. Imagine that it is having more than 100 or 200 features means this computation and all things we cannot possible at all in explaining. That's why we are taking only two simple model for explanation purpose. For better realization, please go with the Python code. How SENN is working, you can develop your own Python code and you can test what are the things happening, how the models are computing, how the prediction they are explaining. Everything is possible by means of just running a Python code. Many Python codes are available online. Meanwhile, in the next video lecture, I will try to demonstrate a Python demonstration on SENN and concept whitening. so that we can realize what we have learned in this topic. Instead of tiny data set, we will take one real data set and then we will implement a CNN to check what are all the features and its predictions, how possibly it is predicting, explaining the prediction to the users. These are all things we will check in the next class. Thank you for sharing your time and watching the video. Realize the concept and understand the concept and work in a better manner. Try to develop good research papers based on the new concept by hybriding more and more technique algorithms together. By embedding more algorithms into a single frame, you can do wonders with explainable AI. Thank you very much. Have a great day. Nice to have you all in this time. Thank you very much.